Very good morning. So today's topic for the subject discrete mathematics is principle of inclusion exclusion. The contents are derived from Kenneth Rosen's prescribed textbook for the subject discrete mathematics. Let us look at the concept of principle of inclusion and exclusion. Let us try to understand this. There is a set A and there is a set B, and we take the union of this set A and B. So there is a set A, there is a set B, we took a union of set A and B. The number of elements in the union of this set A and B will be what? It is elements in A plus elements in B minus A intersection B, which occur repeatedly. So this is the formula we will stick to. Number of elements of A union B is equal to number of elements in A plus number of elements in B minus A intersection B. So that in the Kenneth Rosen textbook itself, I derived few examples. So this is the first example. So there is a class, there are students in the class. The class is for discrete mathematics and the major is either computer science or mathematics, major as in degree. So computer science majors are 25 students, mathematics majors are 13 students, and the students who are majoring in both computer science and mathematics are 8. So we have to calculate how many students are there. We can have a look at the Venn diagram also. So number of students in set A, which is 25, number of students in this B, which is 13, and A intersection B, which are majoring in both computer science and maths, this is 8. Now using this formula, number of elements, because there are two sets here, set A and set B, computer science and mathematics, and we have to calculate the number of elements of the union of these two sets. So this will be the formula, number of elements in A plus number of elements in B minus A intersection B. So number of elements in A is 25, in B is 13, and A intersection B is 8. So the total number of students in the class will be 30. So we had seen this formula for two sets, sets A and B, of principle of inclusion exclusion. Now let us assume there are three sets, set A, set B, set C. So for this, the number of elements of union of A, B and C, the three sets will be number of elements in A, number of elements in B, number of elements in C minus their intersections of all the three sets combinations, A intersection B, A intersection C, B intersection C, plus A intersection B intersection C. So this is the formula which we have to stick to for three sets. So let us look at a few notes jotted down with the help of my colleague Srikant. So what you are seeing here, there is something called as U. What is U? U is a universal set. What are A and B? A and B are subsets of this universal set. So you can look at the diagram, Venn diagram also here. This U is my universal set, and there are two sets here, set A and set B, and this is the union of these two sets A and B, and the union of these two sets A and B, for that the number of elements I will be deriving will be number of elements in A plus number of elements in B minus A intersection B, minus A intersection B. So now if this is my formula, number of elements in A plus number of elements in B plus number of elements, A intersection B, A intersection B. Now how many number of elements are there in A only? This will be this part only, right? This is like this from here. So only A. So only A. So only A. Okay. So, but this part will also be there, right? This part will also be there, this part. So like this. So as you can see here, there is one portion here called as 1 we have given. There is one portion here called as 2 we have given, and there is one portion here, there is 3 we have given. This one portion 3 we know that, so these are common elements, A intersection B elements, right? So if you look at this 3 can be directly denoted as A intersection B. 3 can be directly denoted as A intersection B. What 1 can be? 1 can be A intersection, 1 can be A intersection B bar, okay, and what 2 can be? 2 can be A bar intersection B. So now if I want to know what is the number of elements in A, what will be there? 1 plus 3. So it is 1 plus 3. What is 1? A intersection B bar. What is 3? A intersection B. If I want to know the number of elements in B, that will be what? 2 plus 3. So what is 2? A bar intersection B. And what is 3? A intersection B. So now what we have to do? We have to prove LHS is equal to RHS, right? So to prove this principle of inclusion and exclusion. So what will be A union B now? A union B will be equal to 1 plus 2 plus 3, all the elements taken together. That's why here it is written as A union B is equal to 1 plus 2 plus 3. Okay. So, and we know what is 1, what is 2 and what is 3 is. Okay. 1 is A intersection B bar, 2 is A bar intersection B, and 3 is A intersection B. Now what we are doing here is we are looking at this formula or this formula, same. So we have to take number of elements of A, number of elements of B minus A intersection B. So what we are doing here, A is equal to 1 plus 3. 1 plus 3 means A and B bar plus A intersection B. Same thing we have written here. Similarly for B we have written A bar intersection B plus A bar intersection B. Plus A intersection B. Okay. So minus what is remaining? A intersection B. So here A intersection B are cancelled. So what we have here is this part. Okay. So this part will be how much? It is A union B. So hence LHS is equal to RHS. Hence this formula for principle of inclusion exclusion is proved, which is A union B is equal to number of elements in A plus number of elements in B minus A intersection B. So this is for 2 sets. It can go for 3 sets, it can go for 4 sets, and then it can go for generalization called as the n sets. So same is the case here. What we are seeing here, how many sets are there now? Our universal set is U, and now we have 3 sets, set A, set B, set C. Okay, and this is the principle of inclusion exclusion, wherein the number of elements of union of the 3 sets A, B, C will be equal to number of elements in A plus number of elements in B plus number of elements in C minus their intersections, A intersection B, B intersection C, C intersection A, plus there is a common part called as A intersection B intersection C. This can well be depicted by this. Okay, so there is set A, there is set B, there is set C. Okay, we are labeling them as 1, 2, 3, then this is 4, 5, 6, and this is a common portion which is excluded by everybody. That's why it has to be added again. So 1 will be how much? It will be A intersection B bar intersection C bar. 2 will be how much? A bar intersection B intersection C bar. 3 will be how much? A bar intersection B bar intersection C. 4 will be how much? A intersection B intersection C bar. 5 will be how much? A bar intersection B intersection C. 6 will be how much? A intersection B bar intersection C. 7 will be how much? A intersection B intersection C. So, if you look at number of elements of A, how do I get number of elements A? 1 plus 4 plus 6 plus 7. If we want to take B, number of elements for B, that will be 2 plus 4 plus 5 plus 7. If I want number of elements of C, that will be 3 plus 7 plus 5 plus 6. So, this is what it is. Now, as again you go on doing the replacement, and ultimately LHS should be equal to RHS. Hence, that principle of inclusion will be proved for the 3 sets ABC, for the 3 sets ABC. For those 3 sets, one example from Kenneth Rosen textbook is mentioned here. There are total how many students? 1, 2, 3 students. So total number of students we are taking them as 1, 2, 3, 2, 1232. Okay, who have taken Spanish course. So this is the 1, 2, 3, 2 indicates Spanish course students. 879 students have taken French course. So F we are labeled for French. Then 114 students have taken Russian course. So R we are labeling for Russian. Now there are 103 students. There are 103 students who have taken both Spanish and French. So S for Spanish, F for French. So both Spanish and French means S intersection F, common elements. Okay, so that will be 103. That will be 103. Now there are 23 students who have taken both Spanish and Russian. So that will be S intersection R. So there are 14 students who have taken both French and Russian. So F intersection R is equal to 14. Okay. So how many students have taken a course in all the 3 languages, which you have to find out? Which are those 3 languages? Spanish, French and Russian. Okay. So this is our formula. Number of elements for 3 sets is equal to number of elements of first set plus second set minus plus third set minus all the intersection plus the common element. What was the common element? We are referring the common element here, the 7th bit, 7th portion. So that was the common element. So we have this already, this number we know 2092. Rest of the replacements we have done, and at the end that S intersection F intersection R is what? That is actually students who have taken course in all the 3 languages. So as I calculate this, it will be coming to 7. So hope principle of inclusion exclusion was also understandable and palatable to you. Happy learning for discrete mathematics.